Okay, it looks like it, I don't know if I hit the wrong button or not, but it cut me off when I was doing the hole locations. I'll make a more defined print radius, but I was actually able to use dimension, and then I added baseline dimension, and I was able to stack these up, and then I was able to move them because they ended up here. So I was able to move them and squish them down a little bit like that and make it still neat but readable. And then I put in a dimension this way, and I actually put a dimension between. I could have put another one up here, but I was trying to keep it clean. And another trick I learned was this one right here. Hole and note thread. Select hole or thread, specify the location of text. So actually, because I clicked on the hole right there, and I did this, and all of a sudden it populated all that information. It knew everything about the hole. So I'm actually going to undo that. So the only thing I had to change was the, it said 1.1, which it is correct, but it's typically, we call this a through hole. So I just edited this to become through. And in this case, I don't think I really need this 3-place dimension. So I was going to try to edit that particular one. It does look like it's allowing me to. 82.0. All right, just 82. Let me hit close. It's really 82 degree. That's the angle of this up here is 82 degrees. That's a typical, what they call a flathead screw countersink right there. I probably want this to be a little bit, let's see if I can move this to like there. That's a little bit more descriptive. And I don't like these to hit each other, so there we go. I think that's a decent enough print that somebody could use on the shop floor, or actually be able to draw from. You could draw, maybe write a simple program, or use this for inspection purposes. So I think that's a pretty good start right there. Yeah. So now I hit PDF. I'm going to output the PDF, and I want to just view it at the end, but I want to save it somewhere. So I'm going to save it in my directory, or if I'm in my class, I'm going to send it in my. But for right now, I'm just going to put it in on my desktop up here. Give it a little file there, STC class, and I'll put it right here with my initials. Cam milling sit right there, sit save. But if I go into here, and where you save it may not be where you've got this lesson from, so you got to be careful of where you save this stuff. Like this is a previous one I started to work on quite a while ago, and I actually put a note in here for aluminum. So that's probably something we want to put in here, a description of the material. We'll go text, and we'll put it right down here. 6061-T6 aluminum. There we go. I'm going to output my PDF again. I'm going to save it back up here again, hit save. That's my new blueprint, and there it is right here. So I can print this out, and it's my name, drawn by me. I actually probably don't even need to put EFD at the end because it can only be done in my class. So this is enough information. This says 5 times 0.188 through. That's another way you can do. You can do 5 times instead of typical 6 places. That would be another note, like up here. But I think that'll work. So if we printed this out, I'm sure we could make these parts respective. So 2x1 material by 7 inches long. We could obviously machine this in our machine. We were using the same size material, only it's a little bit longer. Probably what we'll do is we'll do some demos of these. This is part of the course, so we probably want to make those. Okay, so let's work on. I'm going to add this as an add-on to the Fusion course on week 3 or week 4 to be able to produce this drawing based on the cam milling setup. Okay, talk to you.